Welcome back my students, Dr. Ugwe here, and today I bring you learning objective number 4, that's consequences of aberrant excitation in the heart in relation to ectopic pacemaker and Wolff-Parkinson-White syndrome. This is the last learning objective from chapter 32, that's origin and conduction of the cardiac impulse. With this question, this chapter is complete. No need to write anything, my handwritten notes are in the description of this video. And in this video, we will also be going to talk about the Stokes-Adams syndrome. So what's our learning objective today? Our learning objective is consequences of aberrant excitations in heart in relation to ectopic pacemaker and Wolff-Parkinson-White syndrome. First, what does this aberrant mean? This aberrant means deviation from normal. Deviation from normal. First, we will study normal excitation in heart, then we will study the deviation from normal. What is the normal pathway of electrical excitation in the heart? We know that heart rate is generated by sinoatrial node or the sinus node. So it generates heart rate. Then it gives those impulses to atrial muscle, atrial musculature, which results in atrial contraction. Then the impulses are given from atrial musculature to AV node. Then the impulses go to AV bundle. Then the impulses go to Purkinje fiber. Then the impulses go to ventricles, which result in ventricular contraction. So this is the normal electrical pathway in the heart. In this normal electrical pathway, this sinoatrial node is dominant pacemaker of heart. Why is sinoatrial node called a pacemaker of heart? Because sinoatrial node generates its own impulses. We do not need to give from external stimulus for the generation of impulses. Sinoatrial node is self-sufficient. And why is it called dominant? Because sinoatrial node has highest rate of impulse generation. So sinoatrial node is dominant pacemaker of heart. It is pacemaker of heart because it generates its own impulses, and it is dominant because it has highest rate of impulse generation. Clear? Now, in this pathway of heart, these Purkinje fibers or AV bundles, these are also pacemakers of heart. That means they can also generate their own impulses, but they are not dominant. And furthermore, when the sinoatrial node gives its impulse to atrial muscle, then it gives its impulse to AV node. And when these impulses reach AV bundle, the impulses from sinoatrial node suppresses the impulses of AV bundle or Purkinje fibers. So the impulses generated by Purkinje fiber and AV bundles, these are suppressed by the impulses from sinoatrial node. Clear? So sinoatrial node is the dominant pacemaker of heart. Purkinje fiber, AV bundles can also be the pacemaker of heart, but they are not dominant. Clear? So this is the normal pathway of electrical excitation of heart in which sinoatrial node is dominant pacemaker of heart. If in this pathway, if any other part of the heart becomes dominant pacemaker of the heart, let us suppose if AV node or AV bundle, Purkinje fiber, ventricle muscle or atrial muscle, if any of these becomes dominant pacemaker of heart, then that pacemaker is called ectopic pacemaker or abnormal pacemaker. Abnormal pacemaker. Why abnormal? Because it is an aberrant excitation. It is deviation from normal. What is normal? Normal is sinoatrial node should be the dominant pacemaker of the heart. If any other part of heart becomes dominant pacemaker of the heart, then we call it ectopic pacemaker or abnormal pacemaker. Is that clear? Simple to understand. Clear? So ectopic pacemaker or abnormal pacemaker is an aberrant thing. That's a deviation from normal. A classical example of this ectopic pacemaker is Stokes-Adams syndrome. We will see in coming minutes what is this Stokes-Adams syndrome. How is it an example of ectopic pacemaker? But before that, these are my notes so far. This is how you will write in your university exams. What is ectopic pacemaker or abnormal pacemakers? When some other part of heart, for example AV node or Purkinje fiber, develops a rhythmical discharge rate that is more rapid than that of the sinus node. In such cases, the pacemaker of the heart shifts from the sinus node to AV node or to the excited Purkinje fiber. Under rarer conditions, a place in the atrial or ventricular muscle develops excessive excitability and becomes a pacemaker. That means ventricle or atria can also become the pacemaker, and that is a ectopic pacemaker, abnormal pacemaker. A pacemaker elsewhere than the sinus node is an ectopic pacemaker. So these are my notes. Go check them out in my Telegram channel. Clearing? What is if there is an ectopic pacemaker in heart, it will called abnormality in blood pumping. Clear? So that's why these ectopic pacemakers are important, because whenever there is an ectopic pacemaker present in our heart, it will result in the abnormal circulation of the blood or abnormal pumping of the blood by the heart. Now, a classical example of ectopic pacemaker is Stokes-Adams syndrome. Now the question is, what is this Stokes-Adams syndrome? What happens is, when SA node gives its impulse to atrial muscle, it results in the contraction of the atrias. Clearly, then the impulse go to AV node, then AV bundle, then Purkinje fiber. Then Purkinje fiber gives those impulse to ventricles, and it results in the contraction of ventricles. So first atria contract, all the blood from atria comes into ventricles, then ventricles contract. This is the normal pathway. But in some people who have AV block, AV block means these AV nodes or AV bundles, they are not able to transmit impulses from atria to Purkinje fiber. So sinoatrial node, it sends its impulse to atrial muscle. It results in the contraction of atria. But the impulses does not reach the Purkinje fiber. Why the impulses are not reaching the Purkinje fiber? Because AV node and AV bundle, we have a block there. They are not able to transmit the impulses. As a result, Purkinje fiber is not getting the impulses. When the Purkinje fiber is not getting the impulses, which implies ventricle is not getting the impulses. When ventricle is not getting the impulses, ventricles cannot contract. So, what happens when ventricles will not contract? Clearly, ventricles cannot contract. When ventricles cannot contract, ventricle contraction is important for flow of blood. So flow of blood does not occur. Flow of blood to body, it doesn't occur. As a result, brain does not get the blood. When brain doesn't get the blood, the person faints. Because brain is not getting the blood, and person faints, then a person regains consciousness. Now the question is, how will the person regain consciousness if its brain is not getting the blood? When this Purkinje fiber, after 5 to 20 seconds, this Purkinje fiber senses that I am not getting the impulses from AV bundle. What happens is that this Purkinje starts to develop its own impulses. I told you in the previous minutes, Purkinje fiber is also the pacemaker of heart. It can develop its own impulses, but it's not dominant. When this Purkinje fiber is not getting the impulses from AV bundle, after 5 to 20 seconds, it senses that I'm not getting the impulses. It becomes its own boss, and it starts to develop its own impulses, and it gives those impulses to ventricles. When Purkinje fiber gives those impulses to ventricles, the ventricles contract, clear, and person regains consciousness. Because now the blood flow is restored. Person regains consciousness. Is that clear? So this Purkinje fiber, it is a defense mechanism. It's a defense mechanism. Initially, Purkinje fiber was getting the impulses from sinoatrial node. So sinoatrial node was the boss of Purkinje fiber. Clear? When there is a AV block, Purkinje fiber is not getting the impulses now. Now Purkinje fiber acts as its own boss, develops its own impulses, gives those impulses to ventricles. Now ventricles contract, and this delayed pickup of heartbeat is called Stokes-Adams syndrome. There's a break of 5 to 20 seconds. Then after 5 to 20 seconds, this Purkinje fiber, picks the heartbeat again. And this delayed pickup is called Stokes-Adams syndrome. These are my notes. You will get them in my Telegram channel. And if this delay period is too long, it can lead to death. So this was all about the Stokes-Adams syndrome. So Stokes-Adams syndrome is an example of ectopic pacemaker, because here the Purkinje fiber acts as a pacemaker. Isn't it? Because normally sinoatrial node should have been the dominant pacemaker. Here Purkinje fiber acts as a pacemaker, so it is an ectopic pacemaker. Isn't it? Now, what is the normal heartbeat in human? Normal heartbeat. Clear? That is 72 beats per minute. It means sinoatrial node, it fires 72 impulses. As a result, ventricles contract 72 times. So our normal heartbeat is 72 beats per minute. But in case of Stokes-Adams syndrome, Purkinje fiber is generating its own impulses, because Purkinje fiber is not getting the impulses from sinoatrial node, and these impulses are given to ventricles. But these impulses are only 15 to 40 beats per minute. Clear? So when Purkinje fiber fires impulses, in that case the ventricles contract only 15 to 40 times. Clear? Because Purkinje fiber develops only 15 to 40 impulses per minute. So this is an example of Stokes-Adams syndrome. Clear? Now moving forward, we are left with a small topic. With that we will conclude this study session, and the topic is Wolff Wolff-Parkinson-White syndrome. What is this Wolff-Parkinson-White syndrome? What is the normal electrical excitation of the heart? Sinoatrial node. It generates heart rate. It gives those impulses to atrias. Clear? It gives those impulses to AV node. Then the impulses go to AV bundle. Then the impulses go to ventricles, Purkinje fibers. Then the impulses go to ventricles, which result in ventricular contraction. This is the normal electrical pathway in the heart. And in this normal electrical pathway, this AV node has a property of AV nodal delay. AV nodal delay. What is this AV nodal delay? Clear? What happens is that when sinoatrial node develops the impulses and gives those impulses to atrias, it results in the contraction of atria. Now the atrias contract, but ventricles are in a relaxed state. This AV node, it holds these impulses for 0.09 seconds. For 0.09 seconds. Clear? When the AV node holds these impulses for 0.09 seconds, so for 0.09 seconds, ventricles remain in a relaxed stage, so that all the blood from the contracting atria comes into the ventricles. When all the blood from the contracting atria comes in the ventricles, then the ventricles contract. So this delay is important for proper ventricular relaxation when the atrias are contracting. Clear? So if they contract simultaneously, there will be problem. So atria has to contract first, so that all the blood from the atria comes in the ventricles, then the ventricles contract, and this is facilitated by this AV nodal delay. This AV node holds impulses for 0.09 seconds, so that ventricles are in a relaxed stage when the atrias are contracting. Isn't it? So this is the normal electrical pathway in the heart. But in some individuals, this normal electric pathway is not present. They have an abnormal pathway between atria and ventricles. Clear? What is the normal pathway between atria and ventricles? So this is AV node, AV bundle, Purkinje fiber, and ventricles. This is the normal electrical pathway. But the persons with Wolff-Parkinson-White syndrome, they have an abnormal electrical pathway between atria and ventricles, and that abnormal pathway is called bundle of Kent. So this bundle of Kent is between the atria and the ventricle, and it is an abnormal pathway, and it is what is called Wolff-Parkinson syndrome. And this bundle of Kent does not have this physiological does not have the property of this AV nodal delay. This bundle of Kent does not have the property of AV nodal delay. As a result, blood from the atria goes into ventricles. The impulses from atria goes into ventricles very quickly, without any delay. So this is Wolff-Parkinson-White syndrome. So my handwritten notes. Wolff-Parkinson-White syndrome. In some individuals, there is an abnormal pathway called bundle of Kent between atria and ventricles. This pathway does not have the delaying property of AV node, so transmission into ventricles is therefore faster. Clear? Most individuals which have Wolff-Parkinson-White syndrome, that means which have bundle of Kent, are asymptomatic. They do not show any symptoms, and this additional pathway can be destroyed by radiofrequency catheter ablation. Isn't it? So these are my notes. You can get them in my Telegram channel. So this bundle of Kent, it is an abnormal pathway between atria and ventricle, and those patients who have bundle of Kent are Wolff-Parkinson-White syndrome. Clearly, as a result, the impulses from atria go to ventricles very quickly because it does not have the AV nodal delaying property. Thank you very much. Your Dr. Droogway here. Keep revising, keep studying. God bless you.